or gun is shot on any man, basically there's first of all a very loud noise, and if the bullet hits the man, he's gonna fall of injury. So what I've used to detect gunshot in battlefields is a sound sensor, a gyroscope. It is a very basic project, but it's very impactful in the military and has a real time use. I'll tell you what it means. So what my sound sensor does is, as you can see here, this is my sound sensor. It reads the sound value in voltages. Basically, it is like it's in the range of 30 to 50, but when there is a loud spike in the sound, it's gonna raise above 900 voltages on speaking. So it's detected as a gunshot. So what will happen when it's detected as a gunshot is, it will give a warning to the command sensor using the Bluetooth module that there was a gunshot at this time, and this is what the decibel change has been recorded, so that it can alert the command sensor. This is only a basic alert, okay? And if you want serious alerts, I have put two-step verification where I'm using MPUs, the MPU 9255, which is an accelerometer. So what it does is it measures your acceleration in a particular axis. Here it is Z axis, because if you're gonna fall vertically down. So when you fall, your the G force acting on the gyroscope is gonna increase. So when the G force increases the given threshold by me, which is gonna be tested practically, like what can be the G force in a fall, in a gunshot fall. So when it exceeds the threshold and there is a bullet sound detected simultaneously at the same time, it is gonna give a high alert to the command center. So basically what happens is, it will give like a lengthy message. That message is the amount of spike detected, the baseline of the spike, the force G acting on the gyroscope when the fall happened, the fall time, fall height, the body temperature, which is going to be measured by the DHT11 at that time, and the pulse reading, which is going to be measured by the heart rate pulse sensor. And it's going to send a critical alert if the heart rate sensor gives the reading below a given threshold. Like if a man is like dead, or if he is not like conscious, if he is unconscious, the heart rate's definitely gonna drop. So if the heart rate goes below a given threshold, it can be declared as a possible critical casualty. So what happens is, it's gonna send another warning message 3 seconds after the fall is detected. So here what happens is, there is no scope to give a false reading. Everything is very accurate. And in a battlefield where every second is important, every step should be taken care of, where you're automating such things which will help save time and which will help save unnecessary risk in a battlefield. Like if you are shot in a battlefield, you have to use some of your time to inform the command center that you are shot, which is very valuable time. Meantime, anyone can like come and shoot you. So my project is gonna help many soldiers, and let me show you the coding part of what I have done and the practicals. So let me go to the IDE. This is my code. So my project is currently disconnected, so let's connect it. As soon as I connect it, it's gonna give the message: sentry band initializing, calibrating sound baseline is 78, sentry band active. It's given the first 5-second update, which is 28.9 degrees Celsius, pulse is 59 bpm because my hand is kept off the sensor, sound is 39, and G-force is 1.02. So let me create the scenario of a gunshot. I'm gonna take my project in my hand. I'm gonna create a loud noise near the sensor and drop my project. Let's see what happens next. It says that fall has started because a fall has not yet started still. It has given the critical alert. Possible casualty heart rate is 60 bpm, which is below my given threshold, which is 70 bpm. So let me show you the working of it. I made a sudden sound. So can you see? Fall height 0.25 meters, fall time 0.23 seconds, G-force 2.05, temperature is 25 degrees Celsius, heart rate is 59 bpm, which is below the given threshold. So what it has given? Critical alert, possible casualty, heart rate is 61 bpm, which is below critical. If a man falls again, example, again it has detected a gunshot plus fall. This time fall height is 0.3, time is 0.2, G-force is 2.3, temperature is 29, heart rate is 58. So all my sensors are working fine and my project is also working fine. So this is gonna be very useful in real time in the military operations where you have no time to send alerts to the command center. And if a man is shot and he is unconscious and he is in a very remote place, he's not able to contact anyone, he's not able to move his hands, this system is gonna help him very much. So let me show you the model itself. Please see here, this is the pulse sensor which I'm touching right now. This will measure my pulse in BPMs and give the data. This is the sound sensor module which will measure the sudden spike in the sound. This is the HC05 Bluetooth module which will help in communication. This is the Arduino which I put inside the box right now, and that's the power connection given to it. As you can see here, this is my vibration sensor MPU05 which I showed in the circuit diagram previously. And these are all the connections which I have done. So let me show you the working of it, if it's working or not. So as you can see, it is giving the previous readings. So what happens is, it measures the see, now there was no sound. I was testing it, there was no sound, but I had given an acceleration in the downward direction. It only told that fall has started, but it did not give a gunshot detection reading. So this means that it's working properly fine. So let's see what happens next. Calibrated again. Yes, now you can see that now I moved it slightly, I made a sound and put it down. It gave all the readings, fall height, fall time, G-force, temperature, heart rate, critical update, possible casualty warning. So it's perfectly working. I'm gonna do it again for you. So as you can see, it's reading all correctly, and yeah, that's it. Thank you.